So let's prove triangles similar by angle-angle, side-side-side, and side-angle-side similarity postulates. First off, the difference between congruence and similarity. Congruence means that two shapes are exactly the same size and shape. Similarity means that they're different sizes, but the same shape. Shape is determined by the angles, and size is determined by the side lengths. Okay, so let's start with these two. Let's start with number one and prove that these two triangles are similar by angle-angle. So we see that angle A is congruent to angle D, and angle B is 90 degrees, and angle E is also 90 degrees. And sorry about the messiness of my 90-degree box, but I'm not really good at writing with a tablet yet. Okay, well, if they're both 90 degrees, they must be congruent. So we've shown that two pairs of corresponding angles from each triangle are congruent. And when we show that two pairs are congruent, we're actually showing that all three pairs of corresponding angles are congruent. Because if two triangles of one triangle are congruent to two angles of another triangle, then the third angles must be congruent. So we have to actually show, write down, we have to show that the angles are congruent. So angle A is congruent to angle D, angle B is congruent to angle E. So therefore, by angle-angle similarity postulate, triangle ABC is similar to triangle DEF. Let's look at another example, but using the same similarity postulate, using angle-angle. Here we have a smaller triangle inside a larger triangle. So we want to show that triangle RMQ is similar to triangle SMQ. And in the given, we're told that angle QRM is congruent to angle DSM. And we're also shown that angle M is congruent to triangle SMD because they're the same angle. So by the reflexive property, angle M is congruent to itself. And we're just calling it different names here, angle M and angle SMD, to identify that there's two different really angles here. One angle from one triangle and the other angle from the other triangle. So since these two angles are congruent and this angle by the reflexive property is congruent to itself, triangle RMQ is similar to triangle SMD by angle-angle similarity postulate. Now let's go on to proving two triangles similar by side-side-side. Now, when we use side-side-side similarity postulate, we're not looking at the angles at all. We're just looking at the side lengths, and we're not trying to prove the side lengths are congruent. We want to show that the side lengths all have the same ratio, okay, from one triangle to the other, the corresponding sides. We can also call the ratio a scale factor. So let's look at the side lengths for these two triangles, triangle ABC and triangle DEF. So let's compare the corresponding sides. So we're going to compare AB to DE, and this is a ratio. A fraction is simply a ratio. So we're going to substitute 10 meters in for AB, so 10, and we're going to substitute 15 meters in for DE, so we have 10 over 15. Okay, and to simplify that comes to 2/3. And you could also simplify it to a decimal and make sure that the decimals align. That would be fine. Okay, so we're going to do the same thing with the other pairs of corresponding sides. So we're going to look at BC to EF, and that's going to be 12 to 18. You could say 12 over 18, but we want to keep it in ratio language. So 12 to 18, 2 to 3. Okay, and we're also going to do the same thing to CA and FD. So we're going to have 15 to 20, and that comes to 3 to 4. Well, let's look at these scale factors or ratios. 2/3, 2/3, 3/4, okay? Or 2 to 3, 2 to 3, 3 to 4. Well, these are not all the same. Since they're not all the same ratio, or you could say not all the same scale factor, these two triangles are not similar. So we're going to write the similarity sign, the little squiggly, but we're going to put a line through it. Just like an equal sign with a line through it means not equal, the similarity sign with a line through it means not similar. Okay, let's do the same thing over here. So what we've done is, well, we have 8 feet 8 feet and 10 feet for a little triangle, and we have 16, that's what this kind of shows over here, 16 and 20. So let's look at the ratios from the three corresponding sides with these two triangles. Well, RM to SM is going to be 8 to 16, right? We're going to substitute the 8 for RM and the 16 for SM. We're going to do the same thing for MQ to MD. We come out with 1/2, once again, 1 to 2. And then QR to DS, QR to DS. And we come out with 1 to 2 once again. Since all the ratios are the same, again, you could call them scale factors, they're 1 to 2, then we know that triangle RMQ is similar. So let me just write a similarity in there to triangle SMD. Okay, by side, side, side similarity postulate, because all the sides are in ratios. So unlike angle, angle, we're looking at the ratios here of the sides. We're not looking at congruence of the sides like we did for the angles in angle, angle. Okay, well now we're going to look at side, angle, side. And the side, angle, side similarity postulate is like if the angle, angle and side, side, side got together, had a kid, because it's a combination or it's a hybrid of both of these two postulates. So what we want to do with side, angle, side is we want to show that two corresponding sides are in ratio, have the same scale factor like we did before, and the included angle, that means the angle that's sandwiched between those two sides, those two angles are congruent. So the sides must be in ratio and the angles must be congruent. So let's go ahead and let's do this. So AB to DE, AB to DE, okay, the corresponding sides, 10 to 15, once again, that's 2 to 3. Same thing for BC and EF, 2 to 3. And the included angle, the angle that's sandwiched between the sides, well, it's both 90 degrees for both triangles. So we know that the angles are congruent, right? Angle B is congruent to angle E. Therefore, triangle ABC is similar to triangle DEF, and we should write in here by side, angle, side similarity postulate. And sorry about the messy writing. Okay, and this one, let's just go ahead and change real quick over here, because it's going to be side, angle, side, because that's what we're looking at here. Okay, so let's continue. So we're going to do the same thing with our sides here. Well, this side corresponds to this side. This side of the little triangle corresponds to this side of the big triangle. This side of the little triangle corresponds to this side of the big triangle. Once again, we know that angle M is congruent to angle SMD, really the same angles, right, by the reflexive property. And that's the included angle for the two sides that we're showing are in ratio. So therefore, triangle RMQ is similar to triangle SMD by side, angle, side similarity